Folks, welcome to week two. Here's our discussion post for the week. I hope that you found last week that my introductory video with some guidance on how to set up that discussion post was helpful, and I hope I can do the same thing for you here this week. So this looks to be the first introduction or the initial introduction to differential calculus, and so let's read through this problem. As a reminder, at least one of the digits from your calculus identification number is important to this discussion post, so make sure you have your number handy. So the question here is: the centrifugal force exerted on rotating turbine blades varies directly as the square of velocity. If the centrifugal force of 1.21 times 10 to the 6 newtons is acting on the blades that move at 550 meters per second, find the instantaneous rate of change of the centrifugal force with respect to the velocity as the velocity increases to 800 and some meters per second. Round the answer to the nearest whole number. So before I talk about setting this up, let me go through here and point out a couple key things we need in order to do this. The first idea here is found in the first sentence, and that is there's a relationship that has been established between centrifugal force and velocity. So we will need to first handle that before we go on to anything else. The second thing is here that we're going to be finding the instantaneous rate of change of centrifugal force with respect to velocity. When we talk about the instantaneous rate of change of a function, that is the introduction, or that is the discussion of the first derivative of that function. And then here we're going to want to evaluate that first derivative at some at some certain velocity, and the velocity here is 8a and then 0, so 830 or 840 or 850, depending on what the a happens to be in your calculus identification number. So those are the key things that we need here in order to set this problem up. So kind of going in order here, the first thing that we want to do is we've got to finish up or establish this relationship between centrifugal force and velocity. It says in the first sentence that centrifugal force exerted on rotating turbine blades varies directly as the square of velocity. So essentially what we're seeing here in this equation is that the centrifugal force is equal to some constant, and that constant happens to be the proportionality constant, since centrifugal force and velocity squared vary directly. So the first thing we need to do is find this proportionality constant by substituting the given value of centrifugal force here in newtons. Newtons is a measure of force. So in order to find the proportionality constant, substitute 1.21 times 10 to the 6 newtons for centrifugal force, and then the velocity given here is 550 meters per second. You will square that, and then you can go through the algebra to solve for k. Once you solve for k, in the next step, what I want you to do is simply write centrifugal force is equal to whatever this constant happens to be from your first step times v squared. So you'll have F of c equals some numerical value times v squared. The next step here will be your first calculus step. So this is a function, centrifugal force is a function of velocity. So the notation here, and again, remember we made the point up front here that we want to be very careful about the notation here. So what I want you to do is I want you to write this as the derivative, or essentially what we're saying here in the numerator, the derivative of centrifugal force, and then in the denominator with respect to velocity. So one more time, from numerator to denominator, the derivative or the rate of change of centrifugal force with respect to velocity is equal to. So here, what I'm going to want you to do is I want you to take this function that you establish in the second step and then take the first derivative, and that will give you a function of velocity. The final step here is to then evaluate your first derivative at the given rate of change, the velocity of the blade. And once you have found or have substituted your value for a from your calculus identification number, you're going to evaluate the first derivative with respect to velocity at this numerical value. And this notation that you see here that I have presented for you here is in your reading. So again, one of the key things here this week is making sure that we know what the notation is saying and what the notation is asking us to do. So one more time here, what this is asking us to do is after we've taken the derivative of centrifugal force with respect to velocity, that derivative will be a function of velocity, and what you're going to do is you're going to substitute this given rate of velocity for v in that function, and then you will find the instantaneous rate of change, or that first derivative at this specific velocity. And the key thing here is make sure you show your final answer with the correct units. And if you just look at the numerator and the denominator, it should be very clear that the units on your final answer will be newtons per meter per second. So it looks like 4 or 5 solid steps here, and you will have done what I would expect, or what I would consider to be a full explanation of the problem, by first finding the proportionality constant and writing the centrifugal force equation with respect to the square of velocity, then take the derivative and then evaluate the derivative at your given velocity based on your calculus identification number. And I think that should do it for the week. Let me very quickly close this up by reminding you of the 3 components, or the 3 criteria by which I will grade this. Obviously, I'm looking for your best attempt on this in your first post. And again, if you use the template that I've laid out here for you, I don't think there will be any problem. If there is, within 24 hours of your post, I will have some comments to you on where you can brush this up. And I hope that everybody will take a look at my comments and, if necessary, make some adjustments and send that back for final grading. And finally, here again, make sure you're using an equation editor so that your post is very clear, it's easy to read, and it looks professional. So again, this is your first attempt, your first work with differential calculus. If there's any questions, let me know. Have fun, have a great week, and I look forward to seeing a lot of real good discussion posts on the board. Thanks.